Hello all. Earlier we discussed about the basic definitions of vector calculus. Here we are going to the solve the problems on directional derivative. Let us see one by one. The first problem to find the directional derivative. The step one is calculate a gradient del pi. And that is gradient pi is nothing but del pi. Here, the gradient of the function pi of x comma y comma z equal to x squared yz plus 4xz squared plus xyz is calculated as del pi, which is equivalent to dou pi by dou x into I vector plus dou pi by dou y into j vector plus dou pi by dou z into k vector. Here, comparing the those equation, dou pi by dou x is by calculating the above equation, given equation, differentiate given equation pi with respect to x. So x squared comes to 2x into constant term remains same yz plus differentiation of x second term differentiation of x is 1, so 4z squared plus differentiation of x is 1 yz. Similarly, dou pi by dou y. Differentiate pi with respect to y, it means equivalent to x squared z plus xz. Similar way to we have to find dou pi by dou z, which is equivalent to x squared y plus 8xz plus xy. Now calculating the gradient at the some points. So for example, 1 comma 2 comma 3. So substitute the point x y z instead, substitute the points 1 comma 2 comma 3 instead of x y z. So dou pi by dou z at the point 1 comma 2 comma 3, which means the substitute the points x comma y comma z equal to 1 2 3. So 2 we get the answer 54. Dou pi by dou x at the point 1 to 1 comma 2 comma 3 is 54. Similarly, dou pi by dou y at the point 1 comma 2 comma 3 is equal to 6. Dou pi by dou z equal to 28. So the gradient vector at the point is del pi at the point 1 comma 2 comma 3 is equivalent to dou pi by dou x into I vector. That means 54 I vector plus 6 j vector plus 28 k vector. In step 3, we have to find the unit vector of the given direction. So the given direction vector is a vector, which is equivalent to 2i plus j vector minus k vector. The magnitude of a vector is modulus a equal to root of coefficient of I vector plus j vector plus coefficient of k vector. So coefficient of I vector is 2, therefore 2 squared plus 1 squared plus minus 1 the whole square, which is equivalent to root 6. Therefore the unit vector a cap equal to a vector divided by determinant modulus a vector. So which is equivalent to 2i vector plus j vector minus k vector divided by root 6. Next, we can calculate the directional derivative. Here the directional derivative of the dot product of the given gradient at the point and the unit vector. Here directional derivative equal to del pi into a cap, which means the del pi is already we know 54 I vector plus 6 j vector plus 28 k vector into a cap is the 2 I vector plus j vector minus k vector divided by root 6. Here the directional derivative is equivalent to multiply I with I and j vector into j vector, k vector with k vector. Remaining terms becomes 0. which means I into j, I into k is equivalent to 0. The dot product of same vectors are equivalent to 1. The other vectors are 0, which means I into I dot I equal to 1, j dot j equal to 1, k dot k equal to 1. So by multiplying coefficient of I plus coefficient of j plus coefficient of k, we get directional derivative is equivalent to 86 by root 6. So the directional derivative is 86 by root 6 is the answer. Here the concept puzzle of the directional derivative. So the concept which is used to solve the given riddle is path A, path B, path C. Which path will help coolest? So we have to directional derivative is slope along chosen path. This is the solution. Thank you.